Imagine a scenario where electric vehicle batteries become so affordable that manufacturing and purchasing an EV becomes easier than ever before. This future is drawing closer to reality thanks to an unexpected breakthrough by CATL. Recently, CATL unveiled its new sodium-ion battery, a battery that's not only cheaper than lithium but also excels in cold weather conditions. It's being hailed as a cost-effective and powerful alternative to lithium. According to reports, this battery doesn't rely on lithium or cobalt, which means it will significantly impact both battery production costs and the environment. Many experts believe that if this technology is widely adopted, it could revolutionize the EV industry. The question is, what has CATL created that could disrupt the entire EV industry? Is lithium's dominance in batteries nearing its end? And the biggest question, is this technology truly practical or just another overhyped claim? You'll find answers to all these questions in this video, so stay tuned until the end, as the information about to unfold will transform your view of electric vehicles. And yes, subscribe to the channel before continuing with the video to be the first to catch more updates. Before diving into CATL's market-shattering new battery, let's learn a bit about the company. If you have even a slight interest in electric vehicles or the battery industry, you've likely heard of CATL. This Chinese company is regarded as the world's largest battery manufacturer today. The implication is clear. Every major electric car you see today, whether it's a Tesla, BMW, or a giant like BYD, is powered by CATL batteries. Founded in 2011, no one could have predicted that in just a decade or so, CATL would become the kingmaker of the battery world. Headquartered in Fujian Province, China, the company operates massive production facilities that churn out millions of batteries annually. CATL initially produced batteries for mobile phones and energy storage devices, but as demand for electric vehicles surged, the company shifted its focus to EV batteries, and that's where its real growth began. Companies like Tesla, BMW, Mercedes-Benz, Hyundai, Kia, Ford, Honda, and Volvo either purchase batteries from CATL or collaborate with them on projects. Even major Chinese companies like BYD, which manufactures its own batteries, respect CATL's technology. This means that when CATL introduces a new battery technology, it impacts not just China or Asia, but the entire global automotive industry. The secret to CATL's success lies in its commitment to research and development. The company invests billions of dollars annually in R&D to lead the race in developing next-generation battery technologies. That's why, while other companies were focused on incremental improvements to lithium batteries, CATL was already working on innovative batteries like sodium-ion, LMFP, and solid-state batteries. CATL's team comprises thousands of engineers worldwide who work tirelessly to make batteries cheaper, safer, and more durable. There was a time when people thought companies like Tesla would dominate the world by developing their own batteries, but the reality is that companies like CATL are the true game changers. Even Elon Musk's Tesla has relied on CATL batteries for numerous projects, most notably the Chinese-made versions of the Model 3 and Model Y, which use CATL's LFP, lithium iron phosphate batteries. It was CATL that turned LFP technology into a massive success, helping to reduce EV prices to some extent. So now you hear that CATL has introduced a new sodium-ion battery that could replace lithium. Limitations of lithium batteries. What's the real issue? Now, let's discuss the real limitations of lithium batteries, the reason why the entire world is searching for the next big battery technology. When the electric vehicle craze took off, lithium-ion batteries were considered a miracle. They were lightweight, stored more energy, and charged quickly. But over time, their shortcomings became apparent, and today, these drawbacks are the biggest hurdles for the EV industry. First, let's talk about cost. Lithium is a highly valuable metal, and its price has skyrocketed in recent years. While a ton of lithium cost around $6,000 in 2020, it soared to $80,000 by 2022. This price volatility directly affects the cost of EVs, meaning that when lithium prices rise, cars become more expensive. This is why EVs remain out of reach for many even today. Mining lithium is a complex and environmentally harmful process. It's primarily extracted from desert regions or saltwater lakes, particularly in South American countries like Chile, Bolivia, and Argentina. Extracting 1 ton of lithium requires approximately 2 million liters of water. Imagine the damage caused by extracting such vast amounts of water to both the environment and local communities in areas where water is already scarce. Supply chain issues are significant as well. Lithium reserves are concentrated in a few countries, and global demand must be met from these limited sources. China, Australia, and South America are the largest suppliers. This means that political or economic instability in one of these countries impacts the entire EV industry. At times, when trade tensions escalate between nations, lithium supplies are disrupted, forcing car manufacturers to halt production for months. Lithium mining not only consumes massive amounts of water, but also pollutes surrounding soil and air. Numerous scientific reports have found that lithium mines degrade land and destroy local farmers' crops. Furthermore, another metal used in batteries, cobalt, comes from regions in Africa where child labor and inhumane conditions are prevalent in mining operations. This means that the technology deemed green hides a dark truth. Recycling poses another challenge. Millions of old lithium batteries are currently being discarded worldwide, but recycling them is extremely costly and complex. Many countries lack proper systems for managing battery waste, leading to toxic chemicals seeping into the ground and contaminating water sources. Now, let's address technical limitations. Lithium batteries perform poorly in cold weather, with the range of most EVs dropping by up to 30% in cold climates. Additionally, if a battery overheats, it risks thermal runaway, which can lead to battery fires. You've likely heard news reports of electric scooters or cars suddenly catching fire. This is why. For all these reasons, every major company is now searching for an answer to the question, what comes after lithium? Some are working on solid-state batteries, others on sodium-ion batteries. Some see potential in graphene technology, while others are exploring hydrogen fuel cells. The message is clear: the future belongs to the company that can eliminate reliance on lithium. Companies like CATL are now striving to make batteries affordable, safe, and long-lasting. The limitations of lithium have forced a rethink, which is why the world's attention is focused on next-generation batteries like sodium-ion batteries. What is a sodium-ion battery? Now, let's talk about the innovation that has shaken the entire industry, the sodium-ion battery, a battery that uses sodium instead of lithium. You might be wondering, what is sodium? Simply put, sodium is the same substance found in everyday table salt. Yes, that very salt. Now imagine how much cheaper batteries could be if they were made from something as common as salt. This idea drove companies like CATL in this direction, and now they've turned it into reality. The sodium-ion battery operates similarly to a lithium battery, with the key difference being the use of sodium instead of lithium. Both batteries work on the principle of ion movement. When you charge a battery, tiny particles called ions move from the positive side, cathode, to the negative side, anode. When you use or discharge the battery, those ions return to the cathode, and this movement generates electricity. That's the core concept. The only difference is that lithium ions move in one and sodium ions in the other. So if they work similarly, why choose sodium over lithium? The answer lies in availability and cost. Lithium is a rare metal found in only a few countries. Sodium, on the other hand, is abundant in seawater, soil, and even salt. This makes sodium easy to extract, inexpensive, and environmentally friendly, which is why scientists consider it a green alternative. Now let's explore the benefits. The biggest advantage is cost. Because sodium is cheap and abundant, battery costs could drop by 30 to 40%. This would make electric cars, scooters, and energy storage systems more affordable. The second advantage is safety. Sodium batteries have a much lower risk of fire or overheating due to sodium's slightly more stable chemical properties, making them safer. The third major advantage is cold weather performance. Lithium batteries weaken quickly in cold conditions, but sodium-ion batteries can perform at up to 90% capacity even at temperatures as low as -20 degrees Celsius. CATL has demonstrated that its new sodium battery operates smoothly in cold regions, a significant advantage for EVs. The fourth benefit is sustainability and environmental balance. The drawbacks of extracting metals like lithium and cobalt, water waste, land degradation, and pollution are absent with sodium, as it can be easily sourced from sea salt or other natural resources. Now, let's address the limitations. To be clear, the energy density of sodium batteries, how much electricity they can store, is currently lower than that of lithium batteries. This means that while a lithium-powered car might travel 500 kilometers, a sodium-powered car would likely manage only 350 to 400 kilometers. However, technology is advancing rapidly. CATL has achieved an energy density of up to 200 watt-hours per kilogram in its second-generation sodium battery, a significant milestone. Additionally, sodium batteries can work in hybrid systems, meaning a car could use both lithium and sodium cells, reducing costs while maintaining balanced performance. CATL is already working on this model, and some Chinese EV companies are testing it. In a direct comparison, lithium batteries offer high energy density but are expensive, perform poorly in cold weather, and rely on limited resources. Sodium batteries have slightly lower energy density but are cheaper, safer, and more durable. In the future, as production scales up, their cost will decrease further, and with technological improvements, they'll begin to rival lithium. This is why companies worldwide are now researching sodium batteries, not just as a technology, but as a step toward energy independence. CATL's new battery, what makes it special? Now let's get to the real game changer, CATL's second-generation sodium-ion battery. This is the technology said to mark the beginning of the end for lithium batteries. CATL recently introduced its new sodium battery, and this time they've backed it up with data, not just promises. According to the company, the energy density of this battery has reached 200 watt-hours per kilogram, about 40% higher than its predecessor. This is no small feat, as energy density determines how much electricity a battery can store relative to its weight. Higher energy density means greater vehicle range, which is what every EV driver wants. The main drawback of first-generation sodium batteries was their lower energy storage compared to lithium, but CATL has largely overcome this. They've significantly altered the battery's chemistry, using high-capacity materials in the cathode and a hard carbon-based anode design, enabling the battery to store more power and charge faster. CATL's engineers report that this battery can charge to 80% in just 15 minutes. Imagine, this is something even lithium batteries have struggled to achieve. The most impressive feature of this battery is that it's not just effective in the lab, but practical for real-world use. CATL designed it to be combined with lithium batteries in a hybrid pack. Essentially, an electric car can have some lithium cells and some sodium cells, offering two benefits: maintaining the vehicle's range and significantly reducing costs. This concept is so practical that many car companies plan to adopt it by 2025. CATL has also stated that this battery performs exceptionally well in cold regions, operating at 90% capacity even at -20°C, whereas lithium batteries drop to less than half their capacity in such conditions. This means EVs can operate seamlessly in places like Russia, Europe, or the Himalayas, a feature no EV battery has offered before. The second key feature is safety. CATL has designed its sodium battery to make incidents like overheating, short circuits, or fires nearly impossible. Lithium batteries often suffer from thermal runaway, where the battery overheats and risks exploding, but sodium batteries avoid this, making them safe for public transportation, school buses, and energy storage systems. Now let's talk about the price, the real turning point. CATL's new sodium battery costs about 30 to 40% less than lithium batteries, meaning electric vehicles will become far more affordable in the future. Even those hesitant to buy an EV will find them within reach. This is why experts are saying CATL's battery could usher in an era of EVs for everyone. CATL didn't design this battery solely for cars. They've stated it can also be used in energy storage systems, electric two-wheelers, and solar-powered devices, potentially transforming not just vehicles, but the entire energy ecosystem. CATL's vision for this battery isn't just as a lithium alternative, but as a blueprint for an energy revolution. Most notably, the company has made this battery ready for mass manufacturing, requiring no rare metals or expensive chemicals and using simple raw materials. CATL is already collaborating with Chinese car makers like Chery and Jack Motors to develop sodium battery-powered models, with reports indicating these cars will hit the roads by 2025. Challenges: what problems remain? So far, we've seen how remarkable CATL's new sodium-ion battery is: cheap, cold-resistant, and eco-friendly. But the truth is, every new technology faces challenges, and sodium batteries are no exception. Honestly, some hurdles still need to be addressed before they can fully compete with lithium. The first and biggest challenge is energy density: how much electricity a kilogram of battery can store. Today's lithium-ion batteries store 250 to 300 watt-hours per kilogram, while sodium batteries reach only 160 to 200 watt-hours. CATL has made significant strides, but they still lag behind lithium in terms of range. This directly impacts vehicles. A lithium-powered car might travel 500 kilometers, while a sodium-powered one would likely manage 350 to 400 kilometers. Range is a critical factor for consumers, which is why companies are proceeding cautiously. The second challenge is charging cycles: how many times a battery can be charged and discharged. Lithium batteries can last 2,000 to 3,000 cycles, but sodium batteries are less durable. This doesn't mean they're inferior, just that their lifespan is shorter. CATL's new battery has made progress here, but it still needs real-world testing in millions of vehicles to prove its longevity. The third major challenge is mass production. For a new technology to succeed, it's not enough to have a good design. It must be manufactured cheaply and quickly. Lithium batteries already have established global factories, supply chains, and recycling systems, but sodium batteries require new innovations in machinery, materials, and packaging. While large companies like CATL are working on this, smaller manufacturers are still in early stages, so it may take years to produce and distribute sodium batteries globally. Now, let's talk about charging networks. While sodium batteries are technologically superior, it's unclear whether they'll require separate charging infrastructure. Although CATL claims they're compatible with existing EV chargers, some updates may be needed to optimize fast charging. Additionally, charging stations in many countries lack standardization, with each company using slightly different systems. Creating a universal system for this new battery technology will be a significant challenge. Safety standards are another concern. Sodium batteries haven't undergone as much real-world testing as lithium batteries. While lithium batteries have been extensively studied for fire safety, short circuits, and crash impacts, sodium batteries are still new. International safety agencies will need to establish new certifications and standards before they can be used in airplanes, public transport, or homes, a lengthy and time-consuming process. Another interesting challenge is temperature balancing. Sodium batteries excel in cold climates, but perform slightly worse in extremely hot conditions. Testing is ongoing in countries like India, where summer temperatures can reach 45 degrees Celsius. CATL and other companies are developing new cooling technologies to ensure reliable performance in all climates. Finally, there's the economic aspect: investment and transition costs. The global battery industry currently relies on lithium. Switching to sodium would require companies to overhaul their entire setup, from machinery to supplier networks, which is no easy task. That's why many companies are moving cautiously. Despite these challenges, experts believe they're surmountable. Just as lithium batteries faced issues initially but became the global standard within years, CATL and other research centers are rapidly addressing these hurdles to improve energy density, extend cycle life, and enable mass production. Industry reaction: what Tesla, BYD, and others think. Now, let's talk about the real stakes: the reaction of other companies to CATL's new sodium-ion battery. When a technology is this significant and potentially disruptive, it alarms not just individuals but the entire industry. That's exactly what happened here. As soon as CATL unveiled its second-generation sodium-ion battery, companies like Tesla, BYD, Toyota, Ford, Hyundai, and others took notice. The question now is, will these companies adopt it or compete against it? Let's start with Tesla, as batteries always bring Elon Musk into the conversation. Tesla has primarily used lithium-based batteries, specifically CATL's LFP cells. In a sense, CATL and Tesla have a long-standing partnership. But CATL's new sodium-ion battery has forced Tesla to rethink its strategy. Elon Musk has publicly discussed exploring hydrogen and new battery technologies, and if CATL's sodium battery proves as promising as claimed, it'll be hard for Tesla to ignore. Some reports suggest Tesla has begun testing sodium battery prototypes in its R&D labs, though the company hasn't issued an official statement. Now let's turn to BYD, China's largest EV maker and CATL's biggest rival. Interestingly, the two companies both compete and inspire each other. BYD has its blade battery technology known for safety and durability, but it also recognizes that if CATL's sodium-ion battery succeeds, it could outshine its LFP battery. BYD recently confirmed its own sodium-ion project, with sources indicating they're using sodium batteries for smaller, affordable vehicles to compete with Tesla and CATL on price. The battle is on, but everyone's holding their ground for now. Japanese and Korean giants like Toyota, Hyundai, and LG Energy Solution are also reacting. Toyota is working on solid-state batteries, but has acknowledged that sodium batteries could be the most viable option for the next 5 years. Hyundai and Kia, both CATL suppliers, have shown initial interest in sodium batteries, with Hyundai stating, "If this battery meets our standards, we'll consider adopting it for our affordable EV lineup." European and American companies like Ford, Volkswagen, and BMW are closely monitoring this trend. The energy crisis in Europe and rising battery costs have these companies searching for affordable, sustainable technologies. CATL has announced plans to produce sodium batteries at its Germany factory, aiming to launch them first in the European market, signaling a global expansion of its sodium technology. Here's the intriguing part. Several companies are quietly testing sodium-ion battery prototypes. You may not have heard this in the news, but industry reports indicate that Tesla, BYD, and Ford have started testing sodium cells in their labs, either with CATL or other research partners. Some are testing low-temperature performance, others fast charging, but no company has spoken publicly yet. They're waiting to see how CATL's first commercial battery performs in the market. Interestingly, Indian EV companies like Tata Motors and Ola Electric are also exploring sodium batteries for their affordable EV segments. If they partner with CATL, EV prices in India could drop significantly. Now the question everyone's asking, when will CATL's sodium-ion battery hit the market? The answer is clear and official. CATL has confirmed that this technology will be ready for commercial production by 2025. The company has already introduced its second-generation sodium-ion battery with an energy density of 200 watt-hours per kilogram. CATL is now moving quickly toward mass production. In mid-2024, CATL announced that its sodium-ion battery would be used in an electric car under Chery's iCar brand. Testing and validation are underway, with initial reports indicating the battery exceeds expectations in stability, charging speed, and cold weather performance. This means the technology has moved from the lab to real vehicles. CATL plans to start mass production of sodium batteries in early 2025, with manufacturing lines designed to produce both lithium and sodium batteries, allowing the company to adapt quickly to market demands. Now, let's talk about market adoption. Since CATL already supplies lithium batteries to Tesla, BMW, Ford, Volkswagen, Hyundai, and others, it's highly likely these companies will adopt sodium-ion batteries once they're commercially available, especially for low-cost EV models. Sodium batteries could be a game-changer, being 30–40% cheaper than lithium. Furthermore, CATL has confirmed that this battery won't be limited to cars, but will also be used in electric two-wheelers, public buses, and energy storage systems, particularly in China and Europe, where demand for energy storage is growing rapidly. Sodium-ion batteries are seen as an eco-friendly and cost-effective solution. Imagine a future where this battery is fully available. The next time you visit an EV showroom, the salesperson might say, "Sir, this new model runs on a sodium-ion battery, not lithium." It charges fast, maintains range in cold weather, and costs less than before. That will mark the dawn of a new era for the EV industry. Industry experts predict that if CATL's production begins smoothly in 2025, sodium-ion batteries could capture 10% of the global EV market by 2026-2027, gradually expanding into affordable EVs and energy storage systems. Now, a bit of suspense. Will this truly change the world, or will it be a limited success? History shows that every new technology comes with expectations and risks. But given CATL's track record, the same company that successfully introduced LFP batteries in 2019, now used by nearly every major EV manufacturer, it's likely that their sodium-ion battery will be a similar game changer. So the question for you is, will this technology reshape the battery world, or will it fade like just another trend? One thing is certain, 2025 will be a pivotal year in the history of the EV industry, as it will determine whether the future belongs to lithium or sodium. And yes, before continuing with the video, subscribe to the channel to be the first to see such factual, exciting updates.